Hello guys, welcome back to Anatomy and Physiology. So this is screencast take 2. So I think I started on the last question on identify 2 ways oxygen is transported around the body and explain how smoking affects oxygen transport. Now, 2 ways oxygen transported around the body is very simple. There's no memory method for that. Oxygen joins with something to make something else, and it's also carried in blood something else. Now, the key thing I'm focusing on is smoking. Okay, so how does smoking affect how oxygen binds to hemoglobin? That's the key focus we're looking at. So how do we use a memory method to remember that? So the way we do it is we kind of respell smoking. So instead of being S at the start of smoking, we're going down to this and it becomes CM, so smoking or smoking. Okay, and what we have is we have the H in there, so we kind of get this concept that when you smoke, carbon monoxide is released into your system. Okay, this then has a higher affinity to hemoglobin than hemoglobin has to oxygen, so this reduces oxygen hemoglobin association. This then leads to a reduced oxygen that is diffused into the working muscles, and then finally this means that you can work aerobically for a decreased amount of time. So translated then, it looks a bit like that. Okay, so first question, binds hemoglobin to oxyhemoglobin plasma. Smoking concept is here. So that's how you would put it into an exam answer. Moving on then. Explain the redistribution of cardiac output or blood flow during exercise. So this is the type of question you could get. So the key thing we're looking for in this question, what has to be in it from the specification? Nothing else has to, it could be cardiac output, it could be blood flow. You're looking for a word, and the word you're looking for is redistribution. Now, in order to get this question right, perfect for a 6-mark question, and I think, it's certainly something that's due. Okay, so I mean, again, this last came up 2011. So redistribution, we're going to respell that word redistribution. So instead of being redistribution, it will be redistribution with 3 V's in the middle. And the reason why, okay, is because in order to redistribute blood flow through the vessels, okay, we basically have to follow the following pattern. Okay, receptors, again, come up, so that's the R. You have to identify the 3 receptors again that we talked about earlier, detect what they detect. Then the information they have enters the vasomotor control center. Okay, vasomotor control center controls or kind of stimulates vascular shunt. It does this via vasodilation, which is the opening of 2 key vessels, and the only 2 you can use are arterioles and precapillary sphincters, and this means that more blood flow is supplied to the working tissues or muscles. Okay, so I'll let you have a look through that, see if that makes sense. That's the concept, that's what's going to be in the mark scheme. This is translate into this. Okay, I'll let you pause that, then I'm going to move on. Okay, there's a bit at the end there if it needed you to carry on. So we'll move on from there. Next one, explain the effect of a warm-up and a cool-down on the vascular system. Okay, so the key thing we're looking at here, there are 3 potential warm-up questions. What you have to make sure you understand is what it's talking about. So warm-up, yes, we would circle that. Cool-down, we would circle that. The key thing we're going to focus on is warm-up and, of course, the vascular system. So in order to get this right, if you warm up, okay, how we're going to make a link is we're going to use this vascular as our link. So if you warm up, you get very, 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 very hot. Okay, so basically you've got that thing here. The vascular begins with a V. Warm up means getting hot, so you get very, 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 very hot. Now what we need to do is understand what these V's need to be put into context. So we have certain things beginning with V that change within our vessels, that in order for us to be able to get more blood to our working muscles during a warm up, they are translated. Vasodilation of arterioles, precapillary sphincters supplying working muscles, we just looked at. Vasoconstriction of arterioles and precapillary sphincters supplying non-essential organs. Vascular shunt, we've looked at there, so increased, or blood flow is increased. Venous return is increased. Viscosity of blood is decreased. That's the only negative kind of thing we're talking about here. And then there is an increase in blood temperature, okay, which is the hot part of the very, 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 very hot. Okay, going on from there, cool down. Cool down, there's no acronym for this. It gradually decreases heart rate, maintains venous return, so we've got another V in there via the muscle pump, and it removes waste products such as lactic acid. Moving on then. So we're coming to the end now of the first anatomy and physiology screencast. So explain how neural control impacts upon the mechanics of breathing for inspiration during exercise. Now the things I've kind of underlined are the things that you should be circling in an exam question. Now first of all, you've got neural control. Okay, so we know neural translates to a certain thing. Now what we need to do is think, what else is the question asking? It's asking us about mechanics of breathing. Now the way I kind of put this across to groups I teach anatomy and physiology is that if you have breathing problems, you wouldn't go to a mechanic. You go to a mechanic if you wanted to get your car fixed. So what we'd say then, if you had a breathing problem, you wouldn't go to a mechanic, you go to a doctor. Okay, so you go to a doctor, and then the next part of the question talks about inspiration during exercise. So what I'm going to do is say this, right, we're getting this kind of image in our head of going to see a doctor because we want to see a mechanic for our breathing. So what I need you to do is, if it's neural control, you are going to use the following memory method. You're going to ring the Dr. VP. Okay, so ring Dr. VP. And this then will translate then, so I put it across this way and I put it down here. So ring Dr. VP. That then translates to the following. Receptors. Okay, so chemo, thermo, proprio, baroreceptors detect what they've detected all along. We've just had a thermo in now, which is an increase in temperature. Now, I mean, you can talk about baroreceptors detecting, acting as a stretch receptor, but, looking back at mark schemes when this came up, which was actually the first ever exam in 2009, the last time that this came up on as a standalone question, it was just happy with people talking about the kind of general information that the receptors detect. Now, because it's the respirator, so it's to do with mechanics of breathing and respiration, this information is sent to the respiratory control center. This then directly stimulates the inspiratory center. Now, as a result of this, okay, we then go on to this kind of concept here. So we're saying ring, the G is silent, and once we've had to ring the doctor, you need to then know Dr. VP and what it stands for. So D is to do with the muscles, or starting with the diaphragm. So during exercise, it's really important you understand that everything that you write about needs to be exaggerated from rest. So you're talking here, so the diaphragm flattens or contracts harder than at rest. External intercostal muscles contract harder or with more force. There are also additional muscles on top. So you've got scalenes, pectoralis minor, or you could have sternocleidomastoid as an additional muscle. All of that comes under the D for doctor. Okay, because diaphragm's the first muscle. Then we need to think of the other muscle that's within the ribs, and then we need to think of those external skeletal muscles that also help. Now, as a result of that, for any bones or group of bones to move, the muscles need to pull or contract. They've contracted. So that then means that the ribs, which is the R from doctor, move further up and out. Okay, this then leads to a thoracic cavity volume, so that's the V, volume, increasing more or further. Okay, directly in opposition, the thoracic cavity air pressure decreases further, and this leads to an increase in the amount of air into the lungs, and that has a net product or net effect of an increase in depth of breathing. Okay, so I'm going to leave it there. That's your first set of screencaster questions, anatomy and physiology out of 3. All right, there'll be 3 sets of these coming, so that's the first one.